5, lesson 7, unit 5, lesson 7. Okay, so we're doing intersection and the zeros. Okay, so those are two ways you can solve using your graph calculator, so we'll go over those. I think we'll just solve with one of them, but then I'll show you how to put the other one in your calculator. I won't completely solve that. But anyways, so these are, now we're adding the equal sign. So before, the first 6 lessons were expressions. An expression is something that is not equal to, that's an equation. So we're adding the equal sign that makes us have an equal to, so we can solve. Sometimes we can solve with our calculator. Sometimes you can solve algebraically. We're going to go over a little bit of both today. So first off, let's use intersection method first. So you can follow me here. I'm going to go ahead and do it on the calculator. So intersect method is you put the left side in y1, the right side in y2. Okay, so in this case, and it's very important these fractions that you use brackets. So I'm going to go bracket 3 divided by bracket, because I want to keep the x plus 1 together. I want to here, you don't have to on this one, I guess. It's a little over brackets, but more brackets is better than less, I always say. But okay, 3 over 3x plus 1 plus 1 divided by x minus 1. Okay, so there's my left side. That's my y1. And then my y2 is just going to actually be 2. I don't know where my window's at, so this might not look great. What's that? Oh, we're good. So put those in. Let's see. Oh, mine's actually pretty good. Okay, so there's my picture. Okay, so we know the rational expressions or equations in terms of graphing come into these asymptote ideas, right? And you can see right here we got a little skinny line going through the middle. But how many answers do we have? 2. Okay, and that's kind of hard to see maybe. But the answers are, let's see here. This right here is an answer, and this right here is an answer. So there's 3 pieces of the graph. There's 1, there's 2, there's 3. Okay. What causes there to be 3? Well, what causes there to be 3 is there's how many asymptotes? 2. Well, there's 3 if you count horizontal, but there's the one here and the one here. But, yes, it's going through this, but that's the 2. That's not part of it. So, okay, but just something to think about. Okay, so let's go ahead and find the intersect method. So again, to refresh intersect, you hit second trace, number 5, intersect. And it's pretty simple actually here. You just hit enter 3 times when you're close to where they cross. Like right now, it's exactly on it. It'll be a little tedious, but we'll just do it anyways. Okay, so the first one is 0, 2. So your first solution, is your answer 0 or is it 2? 0. We're solving for x. Okay, well, so 2 is the other one. Okay, but I meant in this context of this question right here, the y equals 2 isn't helpful because that's just the y equals line. Your answer is 0 for here. And then the next one, yes, the next one will be 2. Okay, so I guess that was somewhat of a trick question. So let's just arrow over. Should come down here pretty soon. There it is. See it come back down. Okay, hit enter 3 times around it. 2. So your answers are x equals 0, x equals 2. That's your solutions for where they cross. You can, but that's assuming that it's going to be a whole number. Okay? So we ask, can you go to the table and see where it's 2? You can, but that's assuming that it's going to equal 2 somewhere perfectly. Okay? All right, so that's the quick calculator way. So now the only thing I'm going to show you for the x-intercept, only thing it changed to do to the x-intercept is you simply take this 2 and you minus it over. So you put a minus 2 on the y1. Okay, if you want to do the x-intercept method. We'll go ahead and just do this too, I guess. So if you go over here, just come all the way to the end here and just put minus 2 at the very end. Okay, so I go minus 2, and now I hit graph again. What happens is your answers are the x-intercepts now, which you can see happens here at 0, happens here at 2. So you get the same solutions. X-intercept or x-intercept or intersect method. Okay, either is fine. Any questions on your calculator for those two? Any questions on your calculator for those two? On the first one? The first one, you shouldn't use the 0. You should use intersect. Yeah. Okay. All right. So we got all that, so we're good. We did the X-Intercept method, so we're good. All right, so now we're going to talk about doing it algebraically. Okay. So the following strategies can be considered when solving algebraically. This is where a lot of you are going to need practice and work with. Okay. So if the equation consists of a single rational expression on each side, use cross multiplication to solve. So what it's saying is, this case, the other rational expression, or sorry, rational versus equals irrational, we cross multiply to get the fractions to go away. And so what that means is I'm putting the x plus 2 up with a 5, the x plus 1 up with the 2, and now your fractions are gone, so you're back to kind of a regular solving situation. We'll do that in a second. Okay? If the rational equation has more than one term on either side, consider multiplying each term in the equation by the lowest common multiple. That's this guy, kind of. See how x is on the bottom here? We don't like the fractions there, so let's just multiply the whole thing by x. Multiply the whole thing by x, you're not going to have any fractions anymore. Okay, and so we'll do that strategy for number 1, or part A. Use previously learned skills for solving linear and quadratic. So we're still doing our factor if we can, if we need to. We're still doing quadratic formula if we have to. We're still doing all those things to solve if we have to for quadratics. Linear is simple, we just solve for x. Okay, it's a single x, right? And then always be aware of your domain restrictions. So we always have to verify our solutions, again, just like with radicals. We've got to make sure that's allowed value. Okay, it might not be allowed, so you plug it back in to make sure it works. Okay? Any questions on that? We're just going to practice these strategies now. Okay, so like I said, for part A here, when you see something like this where it's multiple terms and they have different denominators, go ahead and multiply by the lowest common multiple to get rid of your denominator, which means get rid of the bottom. So I'm going to go x, 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 x. And when I do that, it gets me 4x, x cancels, so plus 2. 7x, x cancels, so plus 3. And see, now we're, to me, like, when you get there, you should be comfortable. Oh, okay, cool. Now we just solve. So I minus the 4x. And these are the parts that I go a little fast, guys, because I kind of expect you, I know I might be going faster than you, but this part to me is like the home free part. Like you're solving for x. This is just mundane. Like it should be easy. I don't want to say that in a mean way. But. Okay, 2 minus 3 is negative 1. 3x. X equals negative 1/3. Okay. Questions or concerns with the first one? Okay. I'm going to show this once, but it gets confusing if you really show this multiple times for people sometimes because they get lost in what's happening. But people have a tough time believing you can just put the x plus 2 over here. So I'll show you what you're doing. What you're doing is you're multiplying x plus 2 to both sides. And when you do it to the right side, that cancels. But then it's up here. You're timesing it. Okay? And you're doing essentially, let me erase that's not written very well. You're doing the same thing with the x plus 1. That cancels. And then you're doing it over here. That's the cross-multiplying step. Okay, that's mathematically what's happening. If you don't like just saying cross-multiply, you're essentially taking the bottom on the right and throwing it to top left, bottom left to top right. Okay, that's why it's called cross, right? So what it looks like when you do this, it's going to be 5 times x plus 2 equals 2 times x plus 1. And again, this to me is the part where now you're good. Solve. Get going. Times the 5 through, I get 5x plus 10. Times the 2 through, 2x plus 2. And we solve from here. X equals negative 8/3. And be aware, if you're doing rational expressions, or rational equations, excuse me, fractions are going to happen. Don't think, oh, it's not whole, I must have did something wrong. Test it. Okay, see if it works. How do you test it? Well, yeah, put it in for x. If you put it on x on both sides, you should get like 4 equals 4. You should get something true. Okay? If not, then it doesn't work. Okay, we're going to verify both of them next. Okay, so this is how you verify. You can do it in your calculator, okay, or you can do it whichever, but you would put it in. So we're going 4 plus 2 over negative 1/3 equals 7 plus 3 over negative 1/3. So you put that in. That's 2 over negative 1/3 is negative 6, plus 4 is negative 2 on the left. 3 over negative 3 is a negative 9, plus 7 is negative 2. Verified. Negative 2 equals negative 2. Use your calculator if you'd like. I just know that when you're dividing something by negative 1/3, that's timesing it by negative 3. That's how I was able to do that a little bit quicker. On the right side, negative 8/3. 5 over negative 8 over 3 plus 1 equals 2 over negative 8 over 3 plus 2. So then that's going to be 5, negative 5/3, and that's going to be 6/3. 2 over negative 2/3. So it's going to be, yeah, so it's going to be, it's negative 3 and negative 3. So it still works. Okay, just verified those two. So any questions? Questions? How to do the next one? All right. So yeah, the next one. Okay, yep. All right, so next one gets a little bit messier. Okay, it still is a what? It's still a rational equals a rational. So they said the strategy is to cross multiply. So yes, you have to cross multiply, and yes, you have to FOIL. So what you do is 2x plus 3 goes here, 3x plus 5 goes here. Cross multiplication. And now you're going to FOIL. So 3x times 4x, 12x squared. 3x times, so that's negative 6x, 20x, so plus 14x. And then 5 times negative 2 is negative 10 equals 12x squared again. I like that a lot. Why? Right, because I don't have any x squareds now, so I'm not going to have to solve by factoring. I'm not going to have to solve by quadratic formula because my quadratic's going away. I have a 12x squared on both sides, so they're going to cancel. Okay, 18x, so that's plus 16x, and minus 3. Okay, so as Joel just said, and he was right, 12x squared cancel, so we're good. Now we're down to that, we're home free. Simple solving. Minus 14x, plus 3. Negative 7 over 2 is your x value. Okay. Right, so yeah, so Jared has said, so what if the x squared doesn't cancel? If it doesn't cancel, then you're going to have to solve by quadratic formula. You get to the unit 3 stuff. You're going to have to figure out using the zero. You can even put in your calculator and find the zeros, but you have to solve the quadratic. So you should expect 0, 1, or 2 possible answers, right? And so that, yeah, that's, you just got to kind of remember unit 3 strategies. Okay, so negative 7 over 2, you could put that as negative 3.5 since that's a unit round. The negative 3.5 is 7 over 2. You could put that in, okay, to verify. I'm going to go ahead and skip the verify step. That's just plugging in the calculator, or you can put it in yourself, but I think you guys get the idea for verifying. Okay. This one does verify, though. Okay, any questions? I'm going to erase this so we have the space to do the next one. We're good? Okay, so this one you're not going to like. Hold on just 1 second. Go ahead. Okay, so Lucas already kind of jumped the gun a bit. He said, so we have to multiply this 3 here by both these denominators. Yes, but you actually have to do, essentially what you're going to do is you're going to times all 3 of these by t plus 1, t minus 3. So this product is going to hit every one. No, Right, because the t plus 1's going to cancel and the t minus 3's going to cancel. We have to FOIL here. So you guys see this? This line, this group right here is going to go to here, and to here. You guys okay with that? So I don't have to write it? And so when you do that, the t plus 1's going to cancel. The t minus 3 is going to cancel. So what this is going to be t minus 3 times 5t minus 2 is the left side, minus t plus 1 times 2t minus 1 equals 3 times t plus 1 t minus 3. Okay? So yes, we have a lot of foiling to do. We have a lot of foiling to do. 3 spots we have to FOIL. All right, so let's get after it. T times 5t, 5t squared. T, negative 2t with a negative 15t, so negative 17t plus 6. Okay, if you want to write it all the way out, you can, guys. I just like to do my combined like terms step in 1. Again, that's to help us go a little bit quicker. Okay, so where I get the negative 17 is I get it. T times negative 2 is negative 2. Negative 3 times 5 is negative 15. So negative 2 to negative 15 is negative 17. Now put a minus here, and we can just go ahead and put brackets, and we'll distribute the negative later. Yeah. 2t squared there. Then we have t negative 1t and positive 2, so it's a positive 1t, negative 1. So that's there. Okay, what's on the other side here? T times t is t squared, hit by a 3, so 3t squared. Negative 3t right here, and 1t, so it's a negative 2t, hit by the 3 for negative 6t. All this stuff you would get if you guys FOIL out and simplify. So if you're panicking, you can ask. 1 times negative 3 is negative 3, times 3 is negative 9. So that's what my right side is. Again, I lucked out because why? 5 minus 2 is what? So my 3's are going to cancel again. Okay, but let's find the left side. So I get 3t squared, negative 17 minus 1, negative 18. 6 minus a negative 1 plus 7, because it's plus. Okay, so like I said, we're happy because my 3t squareds go away, and now we're in the comfortable part where we're solving. So I'm going to add 18t. I'm going to add 9. Okay, so I'm going to get 16 equals 12t. So t is 4 over 3. Okay, when you verify, it is correct still. All right, one more example. Yeah, they are messy. Any questions, though? Okay, so the next one's the kind of most challenging one for this section. We're going to have 3 pieces. Okay, so we'll move down here a second because you guys are still writing, so we'll wait. So the last example here. So what's important in this is, again, when you get these, it's best to have everything factored out so you can see what you're missing or what you need. In this case, x squared minus 16, you want to go ahead and take that down to x plus 4, x minus 4. Because then you can see, okay, this has an x plus 4, x minus 4, just an x plus 4, just an x minus 4. So, what's that? Yeah. So we factor this so that now we see what it comes down to, and we see it's similar. But the point is that we want to do common denominator. We want to get everything to have the same. When you're solving and everything has the same denominator, you can drop it. You don't need it anymore. Okay? So when you're solving, like if I had like 2 over x plus 5 over x equals x minus 2 over x, I can drop the x's. Well, just go back to adding, subtracting, right? What would we do for adding, subtracting? common denominator. And so we would just do it to that single piece. But this one just needs an x plus 4. Because remember, that's not changing a value, right? Because I'm doing it by 1. It's by itself, top and bottom. And yeah, that needs x minus 4. Say it again. Oh, see, no. Okay, good point. So what Nolan said is 1 plus 2 equals 5. Right. Yeah, because remember, we added this. Yeah. People do that sometimes. They can cancel. That's kind of pointless, right? Yeah. So you want to make sure you're doing. So this right here is going to be x plus 4 is on top of the x plus 4, x minus 4. What's that? I'm writing this all out just so you can see it. Okay. So they all have it. And so now we can drop it. And the other way you can think about this too is you could just tell yourself that what we're doing actually is we're multiplying it by everything from the beginning. So maybe that's a better way if you think about it. So you know how up here how we just got a common denominator? You could tell yourself, well, actually, we multiplied by x minus 4. Well, if you divide by x minus 4, then as Nolan said, then that cancels, right? And so it would just cancel things out. But I think it's best to drop the denominator, so that's why I'm showing this way. But you can just forget what I said if I made it worse for you. Okay. All right, so now it's simply this. X plus 4 plus 2x minus 8 equals 5. Okay. It's all right. So then we have 3x minus 4 equals 5. Add the 4. 3x equals 9. The x is 3. You verify that, and it still works. Sure, you can write them x squared minus 16 if you want. Okay. Okay, so why can we just drop the denominators? So actually the reason you can is because in math you can do anything you want as long as you do everything, right? So if I times everything by what's on the bottom, what's going to happen? It's going to cancel all of them. So like if I just said, okay, we'll go ahead and times everything by x plus 4, x minus 4. Cancel, 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 cancel. And we keep doing that. I can do that to everything. I'm OK. And that's what gets it to cancel. So the idea that they all have the same thing in common, we can drop it. Okay, because we can multiply everything by that denominator. Does that make sense? Right. We only did that just to get a common denominator. But now all three of them have a common, so we could multiply again if we wanted. We can multiply everything at this point by this if we wanted. Like that. Well, no, what I'm saying is we leave these here, and now we can cross those. Yeah, see what I'm saying? So since you can multiply everything across, it's going to get them to cross. Nope, that's a good question. Okay, that's it.